Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
All right, greetings everyone, and welcome back to another great episode of IT Pro TV. I'm your host, Daniel Lowry, and in today's episode, we're back with more in our A+ series. That's right, the 22901, if you're paying attention. And joining us back in the studio yet again to help us out with that, our good friend, Mr. Wes Bryan. Wes, man, how's it going today?
Man, it's going great. Great to be up here in the studios with IT Pro TV. That is right. We are moving along, like Dan said, in our very first A+ certification exam. And over the past couple of episodes, Dan and I have been walking you through things like networking, right? Networking communications. And one of the things that we've kind of just briefly hinted at, but, kind of left you with cliffhangers, is that we talked about how data, in networks moves between what's known as a source and destination. And we kind of talked, again, just briefly about addressing. And that's what we're going to look at. We're going to look at, first of all, some of the major protocols that are in something known as TCP IP, kind of introduce you to what TCP IP even is, and then we're really going to be spending some time here in the concept of addressing. So that's what we're going to be looking at in this episode. So let's go ahead and dive right in. And Dan, just like we've done in almost every single episode, we're not shy on acronyms, and we're going to start talking about TCP IP.
Oh yeah, it's always a fun one, right? Don't you just love the acronyms? They just wave over you like a lovely breeze on a spring day. That makes you want to hate life because there's a lot of them. There's a ton of them to go through. TCP IP though, that is one that you want to focus on. This is going to be one that you want to know like the back of your hand because not just for your A+, but as you move on, more certification, this is going to be a very pertinent thing for you to understand. So let's start there, Wes. TCP IP, what does that even mean?
I really don't have any clue.
Well, that's a bummer. Thanks for watching, everyone.
That's right. Wrap this one up. So TCP IP, right? This is actually a protocol suite. The name implies two protocols, right? In some other episodes, Dan and I talked about some of the major protocols and ports, if you will, that you can see that we use for different services. But when we talk about TCP IP, we're not really just talking about transmission control protocol, that connection-oriented service that we mentioned in other episodes that guarantees, a stateful delivery, right? We're going to kind of have our delivery confirmation, we're going to send our email or we're going to send our communication and we're going to find out, hey, is that information, has that data actually made made the trip across the network in maintained its integrity, did it get there in the right order? But we also talk about IP. Now, IP is an interesting one. This is where we get what's known as the Internet Protocol. In Internet Protocol, it is a connectionless service, right? It has no idea of really how to get your information across the network, but it does tell you where the information is going and where it has come from. Now, just when I say TCP IP, I said it is a suite of protocols. So when we talk about a suite of protocols, what do we really mean by that? Well, TCP IP isn't just those two protocols in the fact that it's actually a family of protocols, if you will, and they're kind of like all holding hands, and they are helping get your communications, if you will, across the network. And sometimes we reach out and we tag one of the protocols in so that it can help us, and sometimes we don't use others, and it really depends on what we are trying to accomplish. Now, when we look at our objectives, they call out the two addressing protocols that we have to be aware of. But a little bit more on TCP IP. Understand that TCP IP has been around for a very long time. In fact, the earliest days of what was known as the ARPANET before it was later given over to public domain, it was reinvented or renamed as the Internet. It was really just militaries and universities, if you will, and really just a handful of them that were communicating across this massive interconnected network. And we needed to get information across that. So the Advanced Research Project Agency, a part of the Department of Defense, if you will, DoD, came up with a highly optimized protocol solution that would allow us to do that. In fact, in the earlier days, it was called the DoD Protocol Suite, later renamed. So TCP IP, again, keep in mind, is what we use is that body of DNA protocols, communication protocols, that allows us to move information across the internet. Now, I just briefly mentioned something known as, well, addressing, right? Addressing, when we talk about the Internet Protocol, All right, what we mean is that this is how we identify where the information is going to and where it is coming from. In fact, you can kind of think of it like, for instance, here in the United States, or maybe you're in other countries, they have some kind of postal system, right? We take our snail mail, piece of paper, if you will, and we address it. We stamp the letter and we put it in the mail, and we'll let the mail carrier take it across their vast network. Well, it's really not too much different when you think about network communications. We have an addressing system that lets the devices, they call them intermediate devices, right? We have in networking, if you think about it, we have what are known as endpoints or end systems, right? So let me give you an example. If I was going to send some information directly to Dan, my computer and Dan's computer, right? These would be what's known as the endpoints. You can also think of them as the source and destination of the network communications. Now, when we say source and destination, it's a perspective thing. It's relative to who's sending the communication versus who's receiving it, right? If I'm sending information to Dan's computer, well, I'm the source of the communication. Dan's computer is the destination. Just likewise, if Dan says, yeah, that was an absolute ugly guitar, don't ever send that to me again, that would be Dan being the source of the communication, if you will, and I would be the destination. So now if we take that concept and let's go back to the mail system, source of the information would kind of be like the return address, right? When you put that snail mail letter in there, you have to kind of know where it's coming from. Well, at least the carrier does, right? As well as where it's going to. So in this case, we also have a destination address. And again, the destination address lets the devices that actually handle the communications know where to send it, right? Now the devices we'll talk about in another episode because we do have certain network connectivity devices, and those are called intermediate systems. And what they're responsible for doing is much like our mail carrier systems, they're responsible for inspecting the data, figuring out where it's going to, and then determining the best path to get it there. All right, so again, that's a little bit about what we're going to talk about. Really heavily going to focus in, we might go into multiple parts here, and really heavily in the first part, we're going to talk all about the Internet Protocol and a couple of variants that we have to be aware of for the exam. Now, Dan made a great point at the beginning here, talking about TCP IP. If you're going into computing, you need to know it. You might say, for instance, just like I did when I started out as an A+ technician, well, why do I have to know about networking? Really, when it comes down to it, I've got a computer here. I want to know about the computer. I want to learn how to fix the computer. Well, my A+ instructor gave some admonishment to the class that I first started in, way back when I first started A+ as a student, said if you don't understand networking, chances are you'll deliver the computer in a box and you're not going to touch it after that. And it really comes down to the fact that there isn't many devices that we have, computing devices, that don't connect directly to networks. So even on a basic level, you have to understand it in order to do basic support, okay? So that's why it's important. So let's go ahead and let's dive into something known as IP, all right? We have two primary types of addresses that we really have to know, all right? We have what's known as the Internet Protocol version 4. We also have what's known as Internet Protocol version 6, and we'll talk about the differences between them and why we would need two to begin with. Let's go ahead and let's step back and let's talk about IPv4. All right, in fact, I've got a Windows machine here on my desktop here, and if I look down in the network adapter, my head's kind of covering it up. If I right-click on the little network icon here, right, it looks like a little monitor there with a trident pitchfork, and I open up Network and Sharing Center. And what's great about Network and Sharing Center, it doesn't matter what edition of Windows in, going all the way back to Vista, Windows 7, 8, 8.1, they're all the same, so it really largely hasn't changed. If I open up my network adapter settings, right? My network adapter is what's responsible for the network communications within the network. Well, it has to have an address, right, to be able to send and receive communications. So what we're going to do here is we're going to kind of look at the properties of our network adapter. And if I right-click on it, I can see a couple things. I can see the properties. And in fact, let's go ahead and start at status, right? We'll look at properties here when we talk about how do we configure IP addresses. All right, if I look at the status here, try it again. Apparently, I don't know how to right-click. And I look at details, right? What I can see is that I have a series of information here. There's a lot of different information, guys. We're not really going to talk about all this information here, but what I'm really focused on is this little IPv4 address. Notice that it has a certain value here. And the certain value in this case is what's known as a decimal value. And more importantly, you can see that it's separated by some dots here. You might hear the term dotted decimal notation. Now, when we talk about an IP address, the format is actually 4 individual blocks, if you will, of decimal values. And these, again, that's why we call them dotted decimal value. Now, we're going to go ahead and we're going to open up the hood, if you will, and we'll look at the engine coming up. But understand that underneath all of this is binary. Everything that we see in computing, I don't care what operating system you have, doesn't matter if you have Windows, doesn't matter if you have Unix, Linux, doesn't matter if you have Mac like we have here on some of our systems. Everything speaks binary, which is a series of basically ones and zeros. Now, in an IPv4 address, believe it or not, these 4 blocks are actually called octets. And in the decimal notation, it doesn't really make sense as to why they're called an octet. But underneath, understand that each block is comprised of 8 individual binary bits. Hence the term octet. Octet is shorthand for 8 bits, if you will. That means that an IPv4 address, if you add 4 of those 8-bit octets, is a 32-bit binary number. Now, if you think about it, a 32-bit binary number isn't very user-friendly. All right, and the reason being is, imagine if you had to connect or communicate with a computer and you had to know 32 individual ones and zeros. I tell you what, I can barely remember my own phone number, let alone, if you will, 32 ones and zeros. And at the basic level, that's why this is denoted this way, because decimal notation is a lot easier for us because, well, if you think about it, it's what we deal with on a daily basis. Decimal notation is what's known as a base 10 numbering system, all right? And when we look at base 10 numbering system, understand that we're talking 10 basic values. I don't know what base 9 is, but base 10, and if you look, what the base 10 means, essentially is we have 0 through 9, right? 10 possible values. Now that being said, keep in mind, underneath, our computers are not seeing base 10, right? They speak in another numbering system, and that's known as binary.
The good old binary, right? They give you the ones and the zeros. It's something you probably heard quite a bit as you've gotten into your technological education, as it were, right? That a computer speaks zeros and ones, ons and offs, trues and falses, and this is where you probably are first encountering it as something practical that we'll actually use.
Definitely. You know, in fact, you go all the way back to the earliest days of computing. I can't think of some of the earlier computers. I think UNIVAC was one of them and stuff, but back to the 30s, right? Essentially, your computer is a series of electrical circuits that are turning on and off, right? In the early days of computing, what it was done, one of the things that they used computing systems for, very early computing systems, was to automate circuit switching. If you go back to the days and you look at some of the old black and white shows or movies, if you will, you remember the ladies that were plugging into the switchboards and they were connecting, if you will, all of our different communications? They were our connectivity devices.
Now, Wes, are the CPUs, is that what they're still doing to this day? Basically, is just throwing a switch off and on that's just at a microscopic level?
Absolutely, and it's also at a very fast level, like you and I have talked about in past episodes. A single processor, or in a single second, excuse me, we're talking 4 billion calculations. 4 billion pulses of electricity.
With a B.
That's right.
With a B.
Yeah, with a capital B. So keep in mind that under the hood, that's what we're seeing. And again, because we use a base 10 system here in just normal math, if you will, that's what we're familiar with, and when we denote it, it makes it a little easier for humans to read. Now, there are some things that you have to know about base 10 numbering systems, because they might ask you on the exam to take that 32-bit number, those 4 decimal blocks as we write it and denote it, and convert it over to binary. So that's what we want to look at a little bit, and then we'll go a little bit more into depth on what these individual blocks and pieces mean, but we really want to start there. And it's going to be important because, as, like Dan said, you go into your networking career, there's going to be times when you will have to, and even sometimes from memory and not even writing it out on paper, convert this from decimal to binary, right? Now here at the A+ level, guys, we just want you to know it conceptually. We want you to know what's going on so it makes sense, and as you progress in your career, you maybe move into an MTA exam for Microsoft, or maybe you go farther in CompTIA, you move into Net+, you will have to know it, right? Because we have to know a lot more a little bit later. So going with the basics, I want to go back to our base 10 and our base 2 numbering systems. Now I want to talk about something known as place values, right? Because place values are important when it comes to a single octet. You know, I said that an octet is a series of sequential bits, right? And 8 specifically. I want you to take a number that in decimal that would be 8 place values long. Here, in fact, let me show you what I mean here. So in base 10, right? Maybe you remember this from your basic math, right? Base 10, we have 8 place values here. All right, so if I was to write out a number, let's say, I don't know, let's say something like 1, help me with my numbers here, 1, 2, 3, 4, 5, 6, 7, oh, looks like we need one more there. Maybe 10, I should have stuck with 10, right? Mm-hmm. So if I look at a number like this, right, there's 10 place values, all right, I have 10 million. And the reason I know how to pronounce that is because I can look at the very first place value, in this case, from the right to the left, and I could see, well, that first 0 is in the ones place value. And then we go tens, 100s, 1000s, 10,000s, right? This is just basic base 10s types of decimal notation, right? It's something that we're familiar with. However, when we look at binary, right, and let me go ahead and finish my diagram here because apparently I'm slacking. When we go call it a base 2 because there's 2 possibilities, a 0 or 1, the place values change a little bit. And this is where sometimes when you first see it, like Dan says, maybe this is the first time you're seeing it, it gets a little confusing. What the heck is going on here and what are these numbers?
Yeah, if you only have a 1 and a 0, how the heck do you get up to 128? But
That's right.
Is the value, correct?
That's right. So if we go, in fact, let's take a second and just expand a little bit more on that, Dan. If we look, that's what, 1 to the power of 0? Right? And we look at the powers next to it, it's 1 to the power of 1, 1 to the power of 2, right? And we keep going all the way over. In this case, if we get 8 place values long up to 10 million. Well, it's interesting. When you do this in binary, you're going to say 1 to the power of 0 is what? Well, anything to the power of 0 is going to be 1, right? And then 1 to the power of, 1 to the power of 1, 1 to the power of, or is that right? No, I'm sorry, 2.
Yeah.
2 to the power of 0. Let's get this right, Wes. 2 to the power of 0, 2 to the power of 1, and then we keep going all the way over to 128. Now, the reason we're doing this is because I want you to understand, remember what we said. When we said what an octet is, an octet essentially is 8 1s and 0s. All right, so let me go ahead and get back in here and find out where we're going here with this. All right, so if I look at an octet, I'm going to be looking at, let's say something like this right here. And let me bump up that font size, guys, so you can actually see that. There we go. All right. All right, so this is what one of those blocks would look like as the computer is seeing it, right? They would see the 8 bits in the octet. Well, if I look, I want you to think back to our place values, right? We've got right here, we've got a 1 place value, 2, 3, 4, 5, 6, 7, 8. Well, if you look at the binary system, the base 2 numbering system, the place values work like this. 1, and then they double. 2, 4, 8, 16, 32, 64, and 128. Again, 2 to the power of 0, 2 to the power of 1, all the way out to 2 to the power of 7. Okay? And I want you to know this chart, all right? Because the chart is going to be very, very important in understanding how to take a decimal number and convert it to binary. So that's one of the things that we want to start out with when we look at our IP addresses.
All right, Wes, so we're getting the idea of the place values and how we're coming up with the binary numbering system, but how do we get that binary number into something like when we're looking at the IP address, it said 10.0.14. If I wanted that 10, how do I get 10?
That's a great question. So let's go ahead and let's take Dan's question there and let's turn it into an example. All right. So let's go ahead. Let's move back to our little diagram that we're working on, a little spreadsheet. And again, let me kind of modify this so we can kind of see what's going on here. Let me go ahead and select this. And again, doing this on the fly is always a great idea. Live on camera here, you guys get a chance to watch.
It always goes well, doesn't it?
Yes, exactly. You get to watch me struggle here, guys. So let's go ahead and let's do that. All right. So we're going to take this number first of all, and let's just go ahead and take that out of here. All right. And what we want to do is we want to go ahead and we want to just say, all right, we're going to look at the first octet, right? And we'll take that 10 that Dan mentioned. All right. So we'll go ahead and we'll do exactly that. So what we have to do to take that first block, and in this case it was 10, and convert it over to 8 bits of binary, right? So what we're seeing here is, don't confuse this is the number 10, not a binary
0.
number.
Yeah.
Thank you, right? So let's go ahead and see that. All right, when you are going to do a conversion, all right, of a decimal number into binary, one of the first things you have to understand are these place values like we've mentioned. I want you to commit them to memory. All right, I want you to write them down. When you go into the exam booth and you push start that exam, I want you to write this down. So when you come to the networking sides, your time is precious, right? You don't have to turn around and rewrite this. So it is important. So the formula is very basic. And again, if it's the first time you've seen it, nothing seems basic, I understand, so don't take it for granted, right? Here's how we do it, all right? When you are going to essentially convert a decimal number into binary, you are going to take these place values from left to right and take that value and subtract these place values one at a time. Now, when you can use a place value, and what I mean by that, when you can take that decimal number and you can subtract a place value from it, it becomes a binary 1. Now, if you take that number and you come to a place value and the place value is greater than the number, you can't use it, right? I can't subtract it, so it's going to be a binary 0. Now, you're going to work through each place value and basically subtract all the way to the right. There are no remainders in this conversion, so if you get a remainder, which I have on many occasions, I've learned that how horrible my math is. Okay, go back and recalculate it. So let's go ahead and do that. If you look at the very first octet here, if I was going to take this decimal value 10 and try to subtract 128 from it, with no negative numbers, right? It doesn't work that way. So unfortunately, we can't use that place value. So what happens is this becomes a binary 0 for us. And then I move to the next place value. Now I can't subtract 64 from 10, so you'll see that, hey, there's kind of a repetition here. I can't use this place value either, so we turn that bit within the octet to a 0. Notice I can't use 32. Notice I can't use 16.
The important thing here is to make sure that you understand that you're trying to subtract 128 from 10, not 10 from 128.
Oh, did I say it that way?
No, you
okay,
did. I just wanted to make sure that the audience out there is following along, because for a second there, I was going, what is going on? Oh, I see. That's right. You have to put the 10 on top of the 128, not the 128 on top of the 10, which would work fine.
Yeah, that's right. That's right.
That's why he's getting 0, because 128 minus 10, that doesn't work.
That's right.
Or the other way around.
Yeah, gotcha.
See how easy it is to get like, whoa, we're out in the left field here.
It really, really is. So make sure that when you're subtracting the decimal number, just like Dan said, put it on top and then try to subtract the place value. If you can't, it becomes a binary 0 and move to the next place value. So notice that I can't put 10 on top of 16, right, and turn around and subtract 16. So because of that, what happens? It becomes a binary 0. But I want you to notice something. When I get to 8, if I was to put, not 120, if I was to put 10 over it, I could subtract that, right? I could subtract 10 or 8 from 10. It works, right? So what happens here is that becomes our very first binary 1 within this 8-bit octet. All right, now, when that happens, I want you to keep in mind that we now have a remainder of 2.
And now, to further clarification, we're not saying that you should put a 2 there.
No,
right?
That's right.
We're not taking what equals what 10 minus 8 equals and putting it there. We're just saying, can I subtract 8 from 10? If it's true, yes, put a 1. If it's false, put a 0. That's where we're getting our numbers.
You got it, nailed it. That's exactly what it is, okay? So now what we're going to do is we're going to take that remainder 2, all right? And we're going to go ahead and we're going to see, hey, is it true or false that I can subtract 4 from my value 2? And the answer is false. So if it's false, that means we're not going to put the remainder like Dan said. We're going to put the binary value, and that's going to be 0, right? And then what we're going to do is we're going to take and we're going to put 2 over 2 in this place value, moving each bit within the octet across to the right. Okay, now notice I can subtract 2 from 2. That makes it true, right? So that becomes a binary 1. Now, notice that 2 from 2 leaves me with a remainder of nothing. It's very, very easy that the process in theory is the same. If I say, I've got a 0, can I subtract 1 from it? And the answer is no. Well, it's still going to be the same formula, right? That value is going to become essentially nothing more than a 0. So notice that we went through each one of these place values, and what we end up coming up with is 0, 0, 0, 0 in the first 4 bits, 1, 0, 1, 0. So 10 converted from the decimal notation essentially into the binary notation. It's very simple, right? But let's not stop there. Let's go ahead and let's try another one, right? You might find out as you work through your networking, you might find like a value of like 192, right? Let's give you another example. This is a common octet in your home networks, and you'll see why coming up here in later portions of this little potentially mini series that we're going to run here.
Let's do 168, Wes.
You want to do 168?
I think 168 is more fun.
Okay,
because 192 is kind of easy.
Okay, so 168. Now we're really going to see how bad my math is. I'll do 168 if you'll pull out the calculator
on your computer.
Calculator.
Here it is.
All right.
I'm ready.
So we're going to go ahead and we're going to take 168 and we're going to challenge Dan here. We're going to say, okay, can I subtract 128 from that decimal value 168? All right.
I sure can.
And the answer, just like Dan said, is yes. So that makes it a binary 1 within that place value. Now understand that what we have left is 40, right? I can do that one. I'm not going to be able to do any of the other ones. I don't know about that, right? So we have 40 left. All right. Now I'm going to just move to the next octet and or the next bit, and I'm going to put 40 over there. Can I subtract 64 from 40? And the answer is, well, no, right? So if I cannot use that place value by subtracting it, it is false. It means it's a 0. And then we're going to move to the next bit, all right? And we're going to have 40, and can we subtract 32 from 40? Well, the answer is true. Yes, we can. So that becomes a binary 1. And that leaves us with a remainder of 8. I told you I might be able to do this one,
You're
right?
Good. I'm checking this math here. Yeah. Yes.
Okay. Good. So now what we have is our remainder, right? So we're going to go ahead and we'll move over to the next bit, right? Now we have our remainder of 8. And the question is, can I take 16 and subtract it from my remainder of 8? And like we can't have negative numbers here, that's a must. No negative numbers and no remainders, right? It is when we get down to the last bit.
That'll get your hand slapped.
That's right. Right. The ruler is coming out.
That's right.
So
beware knuckles.
That's right. So we can't use it. It becomes a binary 0. All right. Now we have to keep taking that remainder of 8, and we're going to subtract 8 from 8. And we know that we can do that, right? So that is going to be true. It's going to be a binary 1. Now notice, and let me go ahead and kind of zero these out here, guys, so I don't get confused. Notice that we have a remainder of 0. The formula is still the same. Doesn't matter where within these 8 bits you get, within these place values, if I have 0, I cannot subtract 4 from 0, right? So that's going to be a 0. Again, wash, rinse, repeat. Guys, gals out there, I understand it's a little redundant, but trust me, it'll start clicking, and you guys, it'll make sense to you. Notice I can't use the 0 or the 2 place value because I can't subtract 2 from my remainder of nothing, unless you're my bank account. So I put 0. All right, and apparently I'm changing the place value.
That's fun.
There we go. See, he was right. He is going to challenge me. All right. Notice the same thing goes, ladies and gents out there, with a 0. I can't subtract 1 from a remainder of 0, so it becomes a 0 as well. All right, now, when we want to look at something, a decimal number like 168 in an octet converted over to a binary value, well, we get these 8 bits, right? And you can see 10, 10, 1000. That is an octet equivalent, if you will, in binary to the decimal value 168.
Wes, that was a fantastic demonstration because this can be a very challenging thing, especially to the uninitiated. This is the first time you've ever had to do any kind of binary conversion in your life. It could be like, oh, what are we even doing? This makes no sense. I heard math, that already gave me the sweats, right? I'm already freaking out, but it's not difficult math, and if you know exactly what we're doing and when we're doing it, it becomes very simple, and the more you do it, the more intuitive it even becomes.
Yeah, absolutely. You know, so some of the big things to remember these place values, guys, gals.
Yeah.
Write them down. All right, we've both done this when we were first learning. We had to. You have to commit them to memory, right? It is very simple if you remember, if you start from the right, 1, and then double it out 8 times to 128. Remember that when you are subtracting it, I want you also to keep in mind, subtract from the left to the right. One of the last things I'd like to show you, if we can go back to our binary number here, in order to go the other way. All right, if you have a binary value, this is why we keep stressing the point. Write these place values out, put the binary number under each 8 bits, and add every one of the ones back up, right? So, Dan, if you'll break out your calculator here just because my math is horrible.
Ready to go.
Let's go ahead, let's add 8. Let's add 32. And let's add 128. Tell me what the value is.
The grand total is 168. Look at that.
168. So keep in mind, once you know how to convert it one way, it is simplistic to convert it back the other way, as long as you know these place values.
That's right. The math, like I said, trust me, math, I start going, oh no. He said math, it's going to be tough. It's going to be horrible, right? But it's not anything that none of us learned in 5th grade even. You know what I mean? It's a very simple math. Adding and subtracting, knowing when to do which. So if I'm converting one way or the other, I have to know to add if I want to create a decimal value out of a binary number, and subtracting for taking a binary number and converting it to decimal. So there we go. Very simple stuff. Wes, I know we have more characteristics of TCP IP and networking that we have to go through, but we're out of time for this episode. So we'll have to come back for a part 2. Hopefully you'll join us there. Signing off for IT Pro TV, I've been your host, Daniel Lowry.
And I'm Wes Bryan.
We'll see you next time.
Thank you for watching IT Pro TV.